Next, we look at the idea of the types of reactions that we have, and the first one we have is a synthesis reaction. So a synthesis reaction is a reaction in which the molar mass of one particular product increases, or it could be two. But you have the basic equation for it is you have that A plus B goes to A to B. Now, it doesn't mean that it has to be two things going to one. It could be A plus B plus C goes to part of A or goes to D, and D plus even E. But it's the basic idea that these things are increasing in molar mass. Now, a lot of times you won't see it referred to as a synthesis reaction because generally this is a type of redox reaction. There's usually some sort of change in the oxidation state of one of these numbers. But we'll talk a little bit about more of that later. The second one is a decomposition reaction. And a decomposition reaction is the exact opposite of a synthesis reaction. It is one in which the molar mass of the products actually decreases when compared to the reactants. So these things have a lower molar mass than these things. Now, generally, we refer to these things as a redox as well, because usually there's a change in the oxidation state as well. If you remember redox at all, this has a charge of 0, this has a charge of 0, this has a charge of +1, and this has a charge of -1. So you've changed the oxidation state. So we refer to them as redox decompositions. Next, you look at the idea of a combustion reaction. And a combustion reaction is one in which you're burning a substance in the presence of oxygen. It almost always makes carbon dioxide and water. The reason why I say it almost always does is you can actually burn hydrogen gas. And when you burn hydrogen gas, it will actually make just water. And you can actually burn carbon, and it will just make carbon dioxide. So we say most of the time it's what happens. It's not all the time, but most of the time that's what occurs. Next, we look at the idea of a single replacement reaction. A single replacement reaction is basically whenever these things change partners. So you see that, or not change partners, one replaces the other. So the zinc comes in and it knocks the copper off. The copper is now free. It's not attached to anything, and you have zinc chloride and copper chloride. Okay, a single replacement reaction, anytime you see a single replacement reaction, it is also going to be a redox reaction. Now, what determines whether or not an element will replace another one is something called the activity series. In the activity series is a list of the activity of the various elements. And it does it in terms of stability. So anything that is higher on the list will replace anything that is lower on the list. And the reason why it is more energetically favorable, another way of saying that is it's stable. Okay, lithium, if you put lithium in a solution, it is highly unstable. It does not want to be by itself at all. It's explosive in water. If you were to put it in a solution with zinc chloride, there is no way that the lithium is going to stay in the solution by itself. It is very, very reactive, so instead it'll knock off the zinc. But zinc would knock off iron, and iron would knock off nickel, and tin would knock off arsenic and bismuth and copper, and the lowest one is gold. Now, an interesting thing is if you look at these last metals, these are the ones that we tend to think of when we think about useful things for manufacturing, when we think about metals that have been used for money previously, and they are the least reactive, which makes sense. You wouldn't want to put copper, or excuse me, gold in your pocket and all of a sudden have the gold react and now you have no more gold. Okay, you also need to be familiar with the idea of halogens. These are pretty easy to do. They go in the order of the periodic table. Fluorine will always replace chlorine. Chlorine will always replace bromine. Bromine will always replace iodine. So if I were to have something like lithium chlorine, lithium chloride, and I add fluorine gas, the fluorine gas will replace this lithium, and you'll get an exchange of partners there. You do need to memorize these activity series because the AP test is 60 questions in 90 minutes for the multiple choice. Okay, you can spend some time thinking about these and figure them out, but if you have automatic recall, it can take a question that normally would take you a couple minutes to answer, and you can do it very, very quickly. The next type of reaction is called a double replacement reaction, and it's a reaction in which one of the substances must precipitate out of solution. What you're doing is you're changing partners. Okay, A is going to knock off C, and C is going to knock off A. Okay, whenever this happens, you've got AD and BC. And you actually see an example of that right here. You have silver nitrate reacts with hydrochloric acid to make silver chloride and nitric acid. And the trick to this is one of these things must be a solid when everything is done. And the actual solid here is the silver chloride. This thing precipitates out of solution because it will fall out. It's no longer aqueous. This reaction will not occur if one of the things is not solid. So we call this a double replacement or a precipitate reaction. Precipitate reactions are governed by the solubility rules. And the solubility rules just say what is going to be in a solution and what is going to be out of solution. Now, if neither of the product is insoluble, it will not occur. So if you look at these things, these are general rules. We'll learn a little bit later about KSPs and what actually dissolves in them. But if you look, the alkali metal ions are always soluble. Okay, if you put an ammonium with anything, it will be soluble. Okay, if you look, you have hydroxide. Hydroxide is not soluble except when you put it with one of those alkali metals. So you need to distinguish between what is soluble and what is not soluble using these solubility rules. This is something that you need to memorize relatively quickly so that you have an idea of what reactions are going to occur. Now, we did foreshadow on this a little bit. In pre-AP, you talked about single replacement, double replacement, synthesis, decomposition, and combustion. Really, we're going to stick to the idea of oxidation reduction, which is redox, a neutralization reaction, and a precipitate. Sometimes we will call it something combustion, just as a way to get it out there, but we're going to stick mostly with the top three. Sometimes you will see something called a metathesis reaction. That's an example of a double replacement reaction. And sometimes you'll see displacement, which is a single replacement reaction. So if you look, we have a couple of examples. And the first one we have says we want to classify each one of these reaction types. So the first thing we want to do is we want to classify this as, we want to call it a synthesis reaction, but we also want to call it a redox. Okay, they're both the same thing. It's a synthesis redox. If you want to look at the next one, okay, this reaction right here is an example of, it's a single replacement because you have the zinc replacing the hydrogen, and it is also a redox. The next, you are combining multiple things, so you have a synthesis, which is also a redox. And the last one you are having something fall apart, so it is called a decomposition, and it is also a redox.